Hi everyone, in this video we are going to discuss about some properties, very important properties of logarithm. We already discussed the basic concept of the logarithm and we discussed the possible values of the argument, base and the result of the logarithm. In our previous video, I will provide the link of that video on the description box. Please first of all watch that video, then you will be very clear about the basic concept of the logarithm. Today we are going to learn about some very important properties of the logarithm. Let's write the today's topic name first. Some properties of logarithm. These are very important properties which helps us to solve the particular problems related to these properties. Uh, Here the first property, the product law. The product law of the logarithm. It is the log of the product of the two numbers x and y. Here the log of x and y, log of x times y with base a. Here the x and y are they are multiplied together, so this is called as the product law. This law called as the product law. The log of x times y with base a is equals to log of x with the same base plus log of y with the same base. It is the product law. Log of x times y with base a is equals to log of x with base a plus log of y with base, here is b, with base a, with the same base. This is the product law. This is a. Here the product of the two numbers, the log of the product of the two numbers is equals to the sum of the log of the individual numbers with the same base. Let's prove this statement, this property. This is the called as the product law of log. Let's prove. Here is the proof of this property. Let's suppose the log with base a of x, log with base a of x is a number m. Here we just suppose the log of x with base a is a m, and the another log of y with base a is a n. Here we just suppose log of x with base a is a m and log of y with base a is a n. And from these equations, these first logarithm equations, we can conclude there. Therefore, here this means, this tells us the power of a is m. Here the power of this base a is m to give x. This is the same. These logarithm equations can be converted into the exponential form as a raised to the m is equals to x. This is equivalent, and from these equations we can write in the exponential form. Here the log of y with base a is n. This means the a to the power n is equals to y. These are the exponential equivalent of this logarithm form. And let's do the product of this x and y. So the product of x and y, x times y, let's substitute the value. It is here, the value of the x is here, a raised to the m, times the value of the y is here, a raised to n. And by using the concept of the indexes, here the base of the numbers are same and they are in product form, so we can add the powers. A raised to m plus n, we can add the powers by the laws of the indexes. Therefore, here we got the value of x times y, xy is a raised to the power m plus n. And this can be written, this can be further written By the inverse process, this is written in the exponential form. Let's change into the equivalent logarithm form, and this implies changing this exponential form into the logarithm form. This number becomes the base of the logarithm. This base is the base number a becomes the base of the logarithm, and here the argument of the logarithm will be x times y is equals to m plus n. By the inverse process of the inverse process of the exponential, this is written in the exponential form. We just change this exponential form into the corresponding logarithm form. This a will be the base of the log with base a xy is equals to m plus n, and the value of the m plus n, the value of the m is here, the value of the m is already supposed here, log with base a of x. This is the value of the m, plus the value of the n is here, log with base a of y. Therefore here we prove the log of x times y with base a is equals to log of x with the same base a plus log of y with the same base a. This is the product law of the logarithm. Please remember this property. This is very important property. The log of the product of the two numbers is same as the sum of the log of the each numbers. And similarly we can prove for the three numbers. In case of the 3/4 numbers, similarly we can generalize it. Log with base a x y z is equals to, here the case is for three numbers, this is equals to log a log a x plus log of y with base a plus log of z with the same base a. This is generalized form. We can prove this by the same method. Here this is the first property, the product law of the logarithm. Here we prove this property. And the second property is, let's talk about the second property. It is about the quotient law. The log of x over y with base a is same as log of x with the same base a minus log of y with the same base a. This is the quotient law. This is the quotient law. We can prove this quotient law by the same method. Let's prove. Here is the proof of this property. Here the method is the same. Let's suppose the log of x with base a is a m, and the log of y with base a is a n, and then just x over y, we can take the data from this x over y. From x over y, here the value of the x is a raised to the power m over the value of the y is here a raised to the power m. Before this step, the process is the same. This same repeated, and we just here take the division x over y and then substitute the values, and this can be written a raised to the power m minus n by the laws of indices. Therefore here we got the value of the x over y is a raised to the power m minus n, and this is written in exponential form. Let's change it into the equivalent logarithm form, and this can be written into the logarithm form. This base a will be the base of the log with base a, and here the argument will be x over y, and is equals to m minus n. Here we just write the inverse of this exponential form, which is written in the logarithm form, and let's substitute the values. Here the m is supposed as the value of the m is supposed as the log of x with base a minus, and the n is supposed here log of y with the same base a. Therefore, finally we proved here the log of x over y with base a. This can be written as log of x with base a minus log of y with the same base a. This is very important property. This is called as the quotient law of the logarithm. These two properties are very important properties. Let's similarly discuss about the third property. And the third property is, the third property of the logarithm. Let's talk about it. And the third property is the power law. The log of x to the power y. Here the argument is raised to the power y with base a. Here the log of x to the power y with base a, and this can be written as the y times the power will come in the front, y times log of x with base a. Let's talk about its proof. Let's prove it. Here this property called as the power law. This is the power law of the logarithm. Power law. And let's suppose the log of x with base a is a number. Let's suppose it gives a number m. Here this is our suppositions. We suppose here log of x with base a is a m, and this can be written its equivalent in the exponential form. Exponential form is here. This means that when the value of the a raised to the power m, then it will give x. This can be written as a raised to the power m. A raised to the power m gives x. This is the exponential equivalent of this logarithm equation. Here we just change this logarithm form into the exponential form, and then after changing it into the exponential form, let's put the power of m, and then power of let's take the power of y on the both side. Here we just take the power of y on the both side. Here we calculate the value of the x to the power y, because we need here x to the power y, and this can be written as, therefore x to the power y is equals to here a to the power, here by the property of the indices we can multiply these powers m times y, and this is written in the exponential form. Let's change into the equivalent logarithm form, and then this implies changing this exponential form into the logarithm form. Log with base, here the base will base is here a, log with base a of x to the power y, this is equals to, and the remaining is here m times y. And let's substitute the value of the m. Here the m is supposed as the log of x with base a times the y, and this can be written as, therefore we have the value of the log of x to the power y with base a. This can be written as y times log of x with the base a. This is the power law of the logarithm. This is very important property on the logarithm. This is the called as the power law. Power of the argument here. Power of the argument. Power law. Here in this video we discuss the 4 very important properties of logarithm and their proofs also. Here the proof is very easy. They are very similar steps. We do here we prove these properties by the very basic concepts of exponents and the interchanging relation between the logarithm and the exponential function. let's talk more about the others properties. Here we discussed 1, 2 and 3 properties. Let's discuss more on this new page, and the property number 4. And this property, the property number 4, property number 4 of the logarithm is, it is about the change of the base. We can write the log of x with base a by changing the base of the logarithm. We can write we can change the base of the logarithm as, this can be written as log of let's name a number, let's say a number b with base a times log of this base, this number b of the x. This is the change of base formula, and this is called as the change of base. Here we introduce the new logarithm with a different base, log with base b. It is changed here. The log of a is changed by the log with base a is changed here, log with base b. So this is called as the change of base formula. And let's prove it. This property is called as the change of base property. Let's prove it. Let us suppose the log of x with base b. Here this is our supposition. Let us suppose this is as a m. Here we just suppose the log of x with base b is a m, and this can be written in the exponential form. The value of the x is here b raised to the power m. Here this is written in logarithm form. We just change it into the equivalent exponential form. The b to the power m gives x. And let's take the logarithm with base a on the both side, taking logarithm with a base a on both sides. Here we are going to take the logarithm with base a on the both sides of these equations, and then equations becomes log with base a of x is equals to log with base a of b to the power m. Here we just take the log with base a on the both side of these equations, and the equations will be this. And this can be written, this can be simplified here. Here the concept of the power law on the logarithm is introduced here. We already proved here in this page. We recently proved that the log of x raised to the power y with base a can be written as the y times log of x with the same base. By using the same concept, we can write here, this can be written as log of a with base b times m, or therefore here we got the value of log of x with base a. This is here m times log of b with base a, and here the m is supposed, we suppose the value of the m is the log of x with base b. Let's substitute the value, log of x with base b times log of b with base a. Therefore finally here we got a relation, log of x with base a. This can be written as log of b. Here the base of the logarithm is changed. Here this was a and here becomes the b times this is the, and this can be written in the very simplified form. First log of b with base a times log of b times log of log with base b of x. Here we just prove this property number 4. This is called as the change of base formula. We can change the base of the logarithm as we needed. And let's discuss about the fifth property. Here we discuss the four properties of the logarithm of any number. And the fifth property is, it is about the power of the base. Log of a number x with base a to the power n. This property is based on the power of the base is equals to 1 over the power of the base. Here the base is a and its power is here n. 1 over n, 1 over the power of the base times log of x with base a. This is the fifth property of the logarithm. This is very important. It is related with the power of the base of the logarithm. Let's prove this. Let us suppose the logarithm, and we can use here the power law. In this case, this can be written as the log of x with base a to the power n. This can be written in the change of base concept. This can be written as the log of the base, here the a to the power n of a times log of x with base a. Here we just use the concept of the change of base, which we already proved the change of the base formula. The log of x with base a to the power n is can be written in the form of log of a with the same base times log of x with base a. Here we just use the concept of the change of base formula. And this can be written, let's suppose the log of a, this component, let's suppose this component. Here we just suppose log of a with base a to the power n. Let's suppose this is a y. This is the proof. And let's do some simplifications here. And by using the concept of the exponents, we can interchange this logarithm form into the exponential form. This can be written as a raised to the power n. Here the power of the base, this base a raised to the power n, power is here y, is equals to just a. Here we just interchange the logarithm form into the exponential form, and this can be written as a raised to the power n y is equals to a to the power 1. Therefore, here we by using the concept of the indices, the value of the n times y is here obtained as a 1. We can equate the powers of the same base, and let's write here, and the n times y, and here the y is supposed as the log of a with base a to the power n. Here we just replace the value of the y by this term is equals to, here we calculate here the value is a 1. Therefore the value of the log of a with base a to the power n, this can be written as 1 over, by transposing this n to the right hand side, we got 1 over n. N times y, this is 1 over n. Therefore from this expression, from our first equations, therefore we can write here we obtain here the value of the log a with base a raised to the power n, this component. Therefore, by substituting the value of this on these equations, we got the value of log of x with base a to the power n is equals to just substituting the value of this. Here the value of this component is here, this term is here calculated as a 1 over n. So we can substitute here 1 over n times the log of x with base a. This is the proof. This is the proof. Here in this video we discuss the 5 very important properties of logarithm. In our next video we will discuss more about some remaining properties of the logarithm. Please keep watching. This much for today. Thank you.